add everything. Is so it's like an array list, and an array list is and the array list is so for example, has flip flop, clap, slap.
Your storage time is longer, but lookup time is longer.
It should be right.
Mine's the opposite. My storage time is quick, my lookup time is longer.
So,
Because I didn't want to load the whole dictionary. Use the whole dictionary. So I might as well make the Hallmark.
it's true. You're right. I'm like, no, why not?
Pardon me?
Did you try Tweetbots?
Essentially, like,
It's good. No,
I
that's
had
exactly
it.
that's
I still
exactly
don't like it. Some other day.
So you when you read the
I have very
dictionary,
particular needs.
you like read it and then
Have you tried the list as
It's definitely
Later.
Yeah.
so what do you do?
I read in the dictionary. Set. Because you want to know how many normals there are. So I read the set, and then when I take a word, I check if the words are valid in the dictionary. That's easy. That's constant. It's a set. So I use a set. And then no, it's a tree set. It's a tree set. So
I'm going to call you Dimitri forever. Because I can't remember your name. Close enough.
I take my first word and find the words that are one of my favorites, then use those neighbors one at a time, feel along and check their neighbors until I find them.
Okay, folks. Shall we get going?
Yeah, we literally just swapped it, but yours ends up being better than ours.
I don't know.
How are you?
Even though our worst case scenario is the
Okay, so let's get going. So we're going to talk about scale today, but before we do, I want to talk a little bit about tomorrow. I hope everybody knows that you're meeting with your product reviewers tomorrow. What? I know. And I put up on the site, you can look at it because this thing is currently not working correctly, some specifics that I'm going to tell, I would like to make sure you guys have for tomorrow's meeting. And I will let the product reviewers know the same so they'll know what to expect. And they are. I'd like you to be able to show them your showcase demo script in words. In other words, not actually a demo necessarily. I'd like you to show them the detailed task list of everything that you still believe you have to do to get to the showcase. Stuff we talked about last week. I would like you to show them the source code for your product so they can poke around at it and see the quality of your code and the quality of your thinking. And by the way, some of the product reviewers will be more or less programmerish, so they might say, oh, I don't know, I'll look at code, but that's okay. They'll still want to look at it. And of course, a demo of the product that you have so far. And remember that at this point, it's getting more important, but not quite ultimately important yet, to pay attention to the fit and finish, to what the thing looks like. You still have time, but it's starting to become more important. And also show them the unit test that you have in your code, and show them the unit test running. Okay? So I'll let them know to keep an eye out for that. Secondly, I'm rebooting this thing now. Secondly, I would like you to, during the meeting, remember, it's the old story. We got these people that are professionals. They're very happily spending time with you guys. Use the time well. They can give you advice. They can give you help. They can give you a second opinion. They can resolve disagreements. They can do any number of things. Try to make sure your time is well spent, which means prepare. And show respect for their time, so don't waste it. Come in ready to start going. Show up on time and all that stuff. And then, of course, take notes. General tip for business meetings in general is it's a sign of respect for the other person, whether it's certainly not if it's a professor, but if it's a business associate, to take notes, to make it clear that you care about what their opinions are. Just a general tip that you will find handy. Okay, any questions about tomorrow? Everybody feel reasonably well prepared? You have to do a lot of cramming between now and tomorrow to get prepared? Yes? You feel like you're going to be okay? You have the time allocated?
Yes.
You're Epsilon, right?
Yep.
Yeah, okay. How's Epsilon doing these days?
Better than it was last.
That's an evasive answer.
Yeah.
How's it doing, you guys? How do you guys feel about it? Somebody else?
I feel pretty good. Our third member isn't here, so.
Huh?
Our third member isn't here.
Right, yes, right. That is good, that is good. But is he working on project or is he starting?
No, he's working.
He's
He's got our search going.
Yeah.
Pretty good.
Still on search?
Oh, no, he's interviewing for Elasticsearch.
Uh-huh.
Yeah.
What's that?
We're making controllers for it.
You switching to Elasticsearch?
Switching from an external search and
Okay, who else? What other project? Give me a quick snapshot of your status, a little bit more substantive. How about you guys? Yes, thank you.
Okay, we're margin cops.
Yep.
And we're in a good place.
Yeah.
However, we have all these, everybody's been working on something different.
Yeah, you
And
got it.
they're scattered into branches right now.
Yeah.
And we hate GitHub as a group at the moment. Because
Okay.
merging becomes very difficult if there are copies.
I've heard that GitHub hates you too.
Yes.
Yeah.
I think that's the problem.
Yeah.
So,
They hate you back.
Right.
Yeah.
And if we're able to get all of that together
Yeah.
today
Yeah.
and hopefully push the latest version onto Heroku, then we'll be happy to talk to Mike with
Okay, good.
our latest situation.
Who wants to give a quick snapshot of their status? Who else? Oh, do over? Oh no, you're a different team. Yes. Yes.
We finally have pretty much all routing issues fixed.
What project is that again? Sorry.
Surveyor.
Surveyor.
Student panels.
Yeah. Sure.
All routing issues fixed.
Yeah.
Survey creation beginning to come along and
Okay.
actually sent into database kind of correctly
Uh-huh.
ish.
Uh-huh.
The graphic stuff is working fine. Submission and changing of files, of questions that are created, not created stuff is not getting its work yet.
Good.
Beginning to do UI stuff is it looks like shit.
Remember, everybody, rehearse at least once the demo you want to give to your product reviewer. Go through it at least once, so you'll know that you're not going to just fall into a pothole. Hey, Chris, could you email the AV dudes and tell them that it's failing to sync again? I've reset the whole thing. I unplugged it, plugged it back in. It's just not. It's showing up on the screen, but not on the projector for mysterious reasons.
It's just for
I know. But nothing's showing up. That's the problem. It turns blue, but nothing shows up on it. Even if I do this, and it's showing up on here, which means that the part of the system is getting it, but other part is not. Okay. Anyway, who else wants to talk about their current status? Yes.
I think we're pretty far along so far in terms of the actual what we want, like the functions and things like that, and we've expanded the database a little bit to include.
What product is it again?
This is Campus GPS.
Yep.
We're basically just focusing on making it look better and making it feel smoother for the showcase day, because all the hard, algorithmic stuff and all the hard, I don't know, just trying to figure out what we have to do in order to make basically a better overall user experience and not have it feel like a clunky, just map thing.
Okay. Who has not yet made a comprehensive list of things that still have to happen by showcase day? Give me an honest assessment so I can beat you up if you say no. No. You guys, okay, that's honest. Anybody else? Have you guys made a list? Now, I'm not talking about story lists. Like literally just sit around saying, I gotta put this checkbox here. I gotta do this. Have you guys done it? What project are you on? Yeah, okay. Have you guys done it? What project are you on? What project are you on? Oh, you also? Okay. Campus GPS? So one campus GPS over there, the other one's over here. Yeah. Oh.
No.
Oh, over there. Okay. It's like a shell game. How about you guys? Did you make a list?
Yeah, we have to make calendar.
A detailed list? Like a little things? You're in the same project as them? Is it in the camera? Can you email it to me so I can see it? Email? No, really, I'm serious.
I'm serious.
Okay, send it now. Okay. Something happened now. How about you guys? Do you have a list? Detailed list? Detailed list? Okay, good. I'll be checking my email. Come on. All right. Everybody going to Socrative again, real quick. This is going to be very fast. You know how to do it. Mm-hmm. Go into Socrative. Yeah, it's room Pito. Yep, correct. And before you type anything, think about this. Give me a real answer. Think about this. For you on your team, think about what percent are you done towards getting to showcase day. In other words, I feel like we're 50% done. I feel like we're 99% done. Nobody's going to be below 50. But where do you go? And I'm just curious to see how different team members view the same thing. So give it a little serious thought and just give a number, estimate. How close are you to being ready for Showcase? Showcase Day is a month away because it's not like it's around the corner. You have a whole month. There's a vacation in there. Give it a little thought, okay? Pardon? I haven't. I want you to think first before I start the activity. Okay, don't talk to each other. Don't. I'm stalling because I'm only now putting the stuff in here. Wow. You guys kind of screwed up, but okay. Save. Come on, where do I save it? Come on. Add. Nope, that's not it. Done. Save and quit. Here we go. Okay. Percent done. It's taking me so long that you'll have it, your percent done will be higher. Oh. Okay, go. Go. Thank you. All right.
Oh no, I got it.
Go.
Jack Harkness. I know, right?
This is Jeffrey. I give the answer.
Awesome. So there's 5 of you that have not logged into Socrative. Okay, there's still time. Okay, good. We're in. I think everybody's voted. Okay. Interesting. God, this is so weird. All right. Thank you very much. Let's go to the. I'll look at this later, obviously. Let's go to the content of today's class. You're welcome to use your computer or just listen. So here's a question for you. Let me turn this thing off. Scalability. What does the word scalability mean to you? When somebody says that you have a scalability problem or you need to improve scalability, what does that translate to for you guys? Yeah.
You can't throw money at profits go away.
I don't know. That means that would be an insoluble scalability problem. But in general, what makes a scalability problem? What are the characteristics?
It would work for the product is good for like a small number of users, but when you expand, it's hard to expand your product to work for more users.
Exactly. So it could be the number of users. What happens when you add too many users?
You add more servers.
No. What happens? What bad thing happens?
Oh, a service crash and
Or just first, before things crash, what happens? Get slow, right? Yeah. What's going on GitHub right now? Anybody heard about it? What's going on?
China or DOS.
Well, we don't know for sure. It's China.
It's pretty much China.
You don't know what to read. You think it's China? Why? Does anybody know why? Why is China upset about GitHub?
The reason is that there's a lot of like census software developed on GitHub, so
Uh-huh.
China wants to like shut down all those developments.
I see.
Yeah.
But why don't they just block out GitHub like they block everything else out?
Oh, I don't know.
Because a lot of programmers in China they use GitHub.
Through a
Yeah.
workaround.
Yeah, so if they block GitHub, the
Mhm.
GPA, the economy will have been negatively affected, so they just want to get around.
Mm-hmm.
You can still use GitHub, but use in the community way.
In a what?
In the community way.
So they're only shutting down certain projects on GitHub?
Yes, there are some projects about government censorship.
I see.
Yeah.
But I think they're just going after all of it. So does GitHub have a scalability problem?
Well, it can't handle everyone in China.
It's doing pretty well.
Does it have a scalability problem? Yeah.
Probably not.
Yeah, it's a DDoS thing, right? Who can describe how a DDoS works? Who can describe how a DDoS works? Yes.
Basically, you have like millions of requests to the same server
Yeah.
made, and the server can't handle all those requests, so it crashes.
What does DDoS stand for?
Denial of service attack.
That's one D. What's the other D?
Distributed denial.
What makes it distributed?
Because it's like it can happen from like different computers anywhere in the world.
Can somebody explain how China can do this?
You can redirect traffic.
Yeah, go ahead.
I haven't read that much, but I think there's this service that's used for like censorship on the internet, and and every time that's being used, it's sending a request to GitHub. I think that's what I read.
Well, they can use botnets to like.
What's the botnet?
Well, it's not bot.
It's like usually it's like some sort of like Trojan or some sort of virus on the computers that the person who controls that botnet can cause their computers to make requests to get a website.
Right. So so it's interesting. I think I did read about it. I think that what the theory is that there's a very common website that all many China-based websites go to collect performance data like Google Analytics, and that particular website has been poisoned. So when people go to that, when the website runs some JavaScript on the service to computer analytics, actually they're getting additional software, which turns everybody's computer into an individual player in this distributed denial of service attack, and that's bringing GitHub down. I wonder how GitHub can fight this. I mean, I don't even know. Anybody have any knowledge of what they can do to fight it? Yeah.
So the website you talk about is Baidu.
Okay.
And then what they did is they insert a JavaScript. So when a Chinese user click a Baidu link, the JavaScript will run and then it will kind of access the GitHub,
Mm-hmm.
GitHub link. And then in order to combat that, GitHub actually insert a Java to say that. I think it's here when an user click a link,
Yeah.
a pop-up will appear and say that the website is
Ah.
infected.
The website is what?
The website is infected. Yes.
So that the user will then know that their website is infected.
They will know that there's something wrong with the JavaScript,
Uh-huh.
and it will stop kind of requesting GitHub again and again.
So let's talk about, so that's we agree that that's not technically a scalability problem. I want to draw a quick little diagram here. And I want you to identify, or try to identify what I'm drawing. It's going to take a second. I've drawn this many times. It's kind of like a puzzle. And $100 for anybody who can identify what this is, unless you've seen me do it before, in which case you don't get the $100.
Shopping mall.
Huh?
Shopping.
Close. Yes. The which one? It's Einstein.
You should say.
Oh, you see it?
Oh, yeah.
Okay, so here's the thing. You're the manager of Einstein, right? And it's lunchtime. And you notice that there's a huge line forming. Okay? And your problem is, what do I do about this long line? Because people are starting to complain. What are the actions that are available to you as the manager of Einstein's? Yes?
You can tell the cashier to be quicker.
To tell the cashier to be quicker. That's not a realistic one, but that would be one. Bad manager. Work harder, work harder. Yeah, go ahead.
Add a second cashier.
Add a second cashier. Yep. What assumption do you have when you say that?
There's another place for a register.
Not only that, but you're assuming that a certain problem here is going to be solved by adding a cashier. Right?
There's another.
Tell me a problem that's going on in Einstein which would not be solved by adding another cashier. Yeah.
Food isn't coming out quick enough.
Yeah. Food preparation is not fast enough, right? What other actions do you have that you can take? Yes.
Changing what the cashiers take, so like what express line versus general.
Yes. Exactly. Okay. Yes. Did you have your hand up?
No, I'm gonna-
Okay. So we can add a register. We can add multiple registers. We can speed up food delivery or food preparation. We can decide that one register handles, and you've been around when they add a register here, and that register only will take sandwiches and sodas. Sometimes they add a register over here, which will only take, again, I think, sandwiches and sodas. Sometimes they have 2 or 3 people working back here, sometimes only 1. Sometimes the problem is that there's
You can open up the second Einstein.
sometimes the problem is that supply is that there's under supply, right? So you see the guys with the big carts coming in, and sort of because the sandwich shelves have become empty. So this is a scalability problem, and what we just quickly described are kind of like the actions you take in order to solve the scalability problem in a website or in a product. Okay, so the essence of it is a few things. First of all, being able to measure, being able to see what's going on, to see where the backup is, and to see also how fast backup is different from how fast people are flowing through. Because you can have a backup because too many people are coming. You can have a backup because the traffic is interfering with each other, things like that. So solving scalability problems on websites are kind of analogous to that. Okay, so essentially you can think of, and we think about solving performance problems on websites or in products in general, as identifying bottlenecks and then resolving the bottlenecks. Okay, it comes down to bottlenecks. Where is the traffic piling up? It turns out also that, and this is from practical experience, that it's a never-ending battle. Okay, so no matter you solve one bottleneck, you add a cashier, or you add you change you can even change your menu. By the way, you may have something on the menu that takes a long time to prepare. You might kick that off. So there's any number of things you can do, but the analogy is exactly like that. So one common thread here is, well, there's two common threads actually. One common thread is measurement. One of the classic downfalls for any kind of optimization that engineers like you fall into is to either preemptively try to solve performance problems. That is to say, I know this is going to be slow. I should probably index all the columns in my database. Or, if not preemptively, going like, okay, it's slow, like any of your websites right now, it's slow. I intuitively know what I should change in order to get it a little faster. And both those approaches are defective, and you probably intellectually know that, but you probably emotionally have fallen prey to that. And so it's a good thing to remind yourself when you or one of your team members says, we have to use Elasticsearch, just to pick on something that somebody mentioned, because simple search is going to be too slow. I would argue that's a classic Yagni behavior, because the non-Yagni behavior is, let's do it the stupid way, which is to ask Postgres to do the search and see if we have a problem, and only then bring in a more sophisticated search algorithm, especially when you're introducing a whole new level of technology like bringing in Elasticsearch. Not to pick on you guys, but it's a classic example. There's some cool, actually the A* thing, not to pick on you guys, is similar as well. Probably algorithmic overkill and complexity overkill for the fact that you're going to have 100 or so points. You can do an exhaustive search and do some sorting and get there as easily. I don't know how hard the A* thing was, but in general, the temptation to do something because I know it'll be slow if I don't do it the simple way is a temptation to guard against. Because almost always your intuition, and not you, not me, but people's intuition, just by historical experience, is way off on what problem is causing it to be slow. In addition, when you make a change, you should know what the slowness is that you're trying to resolve, and you should know to measure after you make the change to see if in fact you've resolved the slowness. Because if you introduce complexity and it doesn't solve the slowness, you may not want to keep it, because any complexity is a source of more bugs. So measure. First, don't assume. Don't get ahead of yourself on optimizing. Wait until you have a problem that you can measure and demonstrate, or at least it's intuitively obvious, in a use case that matters to your product, and then find the simplest, cheapest way to resolve it. This applies not just to scalability problems, but for performance problems of all kinds. Now, we all made an assumption, and before I go to that, let me talk a little bit more about performance. I think I've mentioned this in passing before, and maybe some of you can give me more detail about this because I'm not exactly sure. But it turns out that when you're typing into Google, not only into the search box, not only is Google obviously telling you the other options that may match what you have so far, it actually, the browser, especially Chrome, because it's so embedded with Google, is actually receiving parts of the results page, if not the whole result page, guessing which is the one you're going to pick. And the effect of that is what? And the effect that they want of that is what? Yes?
The search appears much faster than actually is.
Exactly. And that's a very good basic principle in performance. The principle in performance is there's actual performance or actual response time, and then there's perceived performance, a perceived response time. And really the only one that matters, up to a point, is perceived response time. Who can mention another yes?
So when Google says like the answer was found in like 0.27 milliseconds or something, is that how long it actually took to get all that information, or just how long it took the page to render?
I have no idea, because if you think about it, I can't even give you, forgetting about what they actually do, I can't give you a scientific definition of what that number should mean. What is it, I don't know what it should mean. Should it mean that, or three other possibilities? I don't know.
So is it just there to like make
it's a random number
generator?
generator.
Oh, that's really bad.
I don't know what it's there for. But okay, you could say it's part of the perceived performance thing, and it's probably an artifact from the bad old days when that really mattered. But it probably, if I imagine being in the shoes of those guys back in the day, where the competition was between search engines based on performance. Now they're all fast. Probably adding a number that said how many milliseconds or microseconds it took improved the perceived performance, even if it didn't improve the actual performance a bit. So that's probably where it came from. At this point, I don't know what it says. But the thing I think is fascinating is that that all this HTML traffic is being generated before you even choose what you're trying to ask for, and all in the service of perceived performance. In this case, it's actual performance, okay? Which is interesting too, because it means it's generating a lot of internet traffic, but it's just text, and text is like the least of the internet's trouble in terms of capacity, right? So text is no big deal. But you know, Google spends a huge amount of research and development dollars on improving speed of communication in general. Okay, so there's perceived performance. Think of another very, very common UI widget, UI pattern, if you will, which has to do with perceived performance. Very, very common. Very common. That makes it look like things are going faster than they are. It makes you not care really about how fast it's going. Perceived performance. Something that we all know in the UI. We've all seen it. There's two things that appear on every platform known to man. No, but every platform. Yes.
Is it the little wheel that turns?
Yeah, the beach ball. That thing. You're right. That's very common. There was a day, probably you guys don't remember this, when you would hit something on an app or on a website, and it would just sit, and nothing would apparently be happening. And people would start like hitting their computer and unplugging it and rebooting it, and so they brought in the beach ball or the spinning thing. That's one. What's a very common one that even predates the beach ball? Yes?
Loading.
Yes, a progress bar. Doesn't speed the download at all, by a bit, but makes the wait a lot more tolerable. Makes it feel like it goes faster. Okay? So these are, and there's other ones of this. So something to think about when you're concerned about performance. Sometimes all you need to do is to make it, give them something to look at. Yes.
This is kind of interesting, but there's some airline websites that actually the perceived performance is slower than the actual performance because it's been shown that if it feels like it's taking a long time to do the results, it means that it's really getting you the best
Interesting.
prices.
Like kayaking, for example?
I actually asked the CTO of kayaking. He said that they don't do that, so it might be some other.
Expedia does that. I just got called by a recruiter from Kayak, a magical unicorn.
And what?
A magical unicorn.
Oh, you mean that there actually is one that calls?
No, that
They called you a magical unicorn?
Yep, because I know graphic design and I know how to code.
Sweet. Okay, so you got the job.
I have no idea.
That's good though. So he knows the CTO of kayak.
Well, I went to a hackathon. He was a judge, so I had to ask him, and
gotcha.
he didn't win probably
Because of that.
He's like, no, we don't.
Yes, we don't. Yes. Well, I know because this is Paul English, right? Very tall guy.
I don't actually remember. He was just at like a
Anyway.
days.
I remember when they first started, it would. I thought when they very first started, I thought what was really brilliant is they had those sort of airline-looking displays with all the different airlines showing up. You know, searching America, searching East. And I asked them, like, it's really cool. They said that's not really true. We're just displaying that to users. And there's other sites like that. I mean, what's the other one that I thought was?
Yes,
It was
this
very.
guy.
Oh, maybe he's no longer CTO. This dude.
So,
That's the dude.
Orbitz and Expedia do the same thing.
Yeah. Anyway, so perceived performance is very important. That's the point I was making. Now, we all talk about scaling as the number of users gets so high that the system gets slow. But actually, there are other metrics. Okay, yeah, generally, the way I think of it is, how many X's per minute can you do? Okay, and they could be logins per minute, and that the site may be running fine, but for some reason, if too many people log in at once, the thing slows to a crawl or dies. It could be transactions per minute. Okay, everybody can log in and they can look around, but if they try to book a flight, the whole thing falls over. It could be total number of users that have an account. If there are more than 1 million people that have an account, then the system gets slow. It could be the total number of people that are logged in. So my point is, there's a lot more metrics that have to do with scaling, but they all generally have to do with large numbers. But each of those scenarios will lead you to a different kind of way to solve that problem. Okay? Okay. So So the question is, and by the way, if this topic interests you, there is a whole course recently renamed to the Software Engineering for Scalability, Cosi 105, which I'm going to be teaching again in the fall. You might be interested in. It's about software design and architecture with respect to scalability. So there's a lot to say about this topic. I'm going to totally not give it enough attention in this one lecture. So what are the things you can do? Okay. So first of all, there's a fundamental idea, concept that people talk about: scaling up versus scaling out. Has anybody ever heard that phrase? Anybody want to dare try to explain it?
Can you repeat that?
Scaling up, and don't Google it. Scaling up. Scaling up versus scaling out. Actually, I don't mind if you Google it because it'll be a very long answer. Scaling up versus scaling out. Okay, actually, I'm sorry. You had your hand up, right?
Yeah. Scaling up is running your app or whatever on more powerful machines.
Right.
By throwing more RAM, more processors at it.
Right.
And scaling out is throwing more machines at it.
Exactly. So one thing you could do if your campus GPS suddenly starts being really slow if there's more than one person looking for a route, that would be a scaling problem. Actually, I would call that a bug. Actually, no. Scaling problems are bugs, in a way. To the extent that the scale does not meet your product objective, it's a bug. But the solution to it is scale. So you could decide one of two things. Okay, well, we're running it on a free Heroku slice, or they call them dynos, and those are extremely underpowered. It's like running your app on an old iPhone, and they're really underpowered. And you can say, really, all we have to do is pay a few more bucks and run it on a faster dyno on Heroku. You might say, no, it's not that. It's that our database of points, because now we don't just do Brandeis, we do every university on the planet. And we have 1 million points, and we have an indexed table that allows us to find things by geolocation. So we have to add some indexing. So given the problem, there's any number of things you can do. But the problem with adding more, there's a few problems. Let me ask you this: what are the problems if I was running Google on one computer in my rack, and it was slow, and I wanted to speed it up? I could get a bigger computer. What are some of the drawbacks and advantages to that technique? Just think intuitively. Think intuitively. If you're a Google or if you're Campus GPS, it's getting slow, you can just buy a bigger computer. What are some of the advantages and what are some of the disadvantages of that? Just intuitively speaking. Yeah.
An advantage I can think of that's easy. Just if you have money, just throw it at it. But then the disadvantage is maybe there's some way that you could fix the code internally so you don't need as many computers. Like, what if your problem is that you have some exponential function and you need 2 to the n servers for it doesn't make sense at some point.
Right, yes.
Well, I know a big disadvantage is that you're going to have a single point of failure.
If you keep one computer. Yeah. That's true, but it does make a big assumption that your architecture, when going to 2 computers, actually now has 2 separate points of failure. It may not, depending on how you
You
go.
use something like RAID or Hadoop to address that.
Hadoop would be a fundamental change to your algorithm. Fundamental architectural change. Yes. Money. That's an advantage. That's a
Disadvantage. More costly
to make it a bigger computer versus buying 2.
for both.
Yeah, that's more, yeah, but I was talking if the solution is, what are the, yes, go ahead.
Well, physical space.
Yeah. No, I think the big advantage is you don't have to change your architecture. You just, order a new computer from Dell, it's bigger than the old one, you move the software over, boom, it runs. Okay? A disadvantage is that's not going to, well, there's 2 disadvantages. One of them is it's not going to last, because at a certain point, you can't get a bigger computer. Also, bigger computers are much more expensive. It's not linear. So a computer that has, 16 processors and, a terabyte of memory might make your app run fast, but it's extremely expensive, and running your app is no longer cost effective. Okay? But really, I think when we...
Yeah, I'm just saying, wouldn't taking advantage of 16 parallel processors present the same architectural issues as running on several computers? Because it's not like, it would be just different to, for example, make a computer better by, increasing the gigahertz per processor,
Yeah.
rather than increasing the amount of processors.
No, you're right. It depends a lot on how exactly your operating system and your programming language does or does not take advantage of the types of processors. And it may require a fundamental rethink of your operating system. I agree with that. Okay. But instead of buying a bigger computer, we want to scale out. So the way we want to scale out, and here's where it gets interesting architecturally, is the ideal outcome is that you have a bunch of computers, and you can think of them as color-coded, with the jobs that they do. So you may have, for example, I won't do it this way, this takes too long to draw. I'll just put it this way. You can have one class of computer called a database server. You can have one which is an app server. You can have an image server. You can have an authentication server. You could have an email server, and so on. You can think about the major functions of your app, and then if you create your architecture in the right way, you can add additional nodes of that type to your architecture, and that's the classic scaling out scenario. But it's not trivial. I mean, it's a fundamental re-architecting of your product and the way the product works, and there's some basic architectural techniques that I'm going to talk about briefly in a minute about how to do that. But so that is fundamentally scaling up versus scaling out. Yes?
Sorry, quick question. Is that what people on Hackers call microservices?
Yes and no. Microservices is contrasted with the more traditional service-oriented architecture. And service-oriented architecture means take your product, your system, and divide it up into major independent services which talk to each other through REST. So you have one computer or set of computers that are your database or your let's say your payroll system, and that's one that's one application with one set of services, and another application with a set of services may be your inventory system. And instead of making that one big monolithic app, you say, no, I'm going to make them two separate apps. I'm going to connect them as services, and that's a service-oriented architecture. Microservices takes that idea to the extreme and says, what if every little thing that my app does is architected as a service? And it becomes not so much a way to modularize from the perspective of, one department does this, one department does that, but to bring it down to such a level of granularity that you can now put it in the cloud easily, you can move things from computer to computer. And the debate around microservices is that, and I've read a lot about this, and about services in general, and it is one of the classic ways to sort of address scale, is that, yes, it sounds cool, especially if each of these categories of box has their own independent database, which you can imagine. Sounds cool because what do you get? You get less contention on a database, you get more independence. If one crashes, the other one doesn't have to crash. Separate teams can build and test the modules themselves. There's a lot of benefits. But what is easily underestimated when people fall into the thrall of this architecture is the complexity is huge. So yes, they're independent, but now you've got this amazing traffic going through all these things, and when something doesn't work, it's like there's no single log file, for example. If somebody logs in and it takes forever, did it fail? Was it the app server that wasn't handling the login correctly? Was it the authentication server, which was for some reason hung waiting to access the disk? Was it the email server that was supposed to send the confirmation and didn't do it? Can't figure it out because it's all in traffic flying around. So the balancing act is sort of the conventional wisdom that I believe now is that service-oriented architecture is great, microservices are great, but don't, the same thing I said before, don't preemptively organize your app into a whole bunch of services just because you think it's the right way to do it. Instead, build your app as one thing, and then when you have evidence, there's two conditions you want to look for. Evidence that separating out the service into this part of the functionality into its own separate service can yield scalability benefits, one, and two, that you understand that the design of the system and the requirements and the specifications of that piece are well enough settled and understood that you're not that you can actually design an interface that's plausible. So don't do it too early. I want to make sure everybody understands what I mean, what we mean when we talk about services in this context. Who wants to explain a little bit more what I mean when I say divide an application into separate services? Because that's a core underlying principle that you all need to understand. I mean, it's not complicated, but you have to see it in your mind's eye.
So Yelp came to Brandeis and actually able to talk about how they do this.
Yep.
But I don't remember specifically how, but basically the idea is just like every single thing that your app does,
Mhm.
just have it be its own separate like process,
Mhm.
so that if something goes wrong with like I don't know the food delivery part of Yelp, for example,
Yep.
you could like plug in something else in the meantime, or
Mhm.
you could easily find out where in the app the problem is, and other parts of the code won't
Mhm.
conflict with that part.
That's
of
all
it.
true, but it's high level. I'd like to hear somebody go to nuts and bolts. Nuts and bolts. What do you think a service is? Anybody? Want to take a crack at it? Okay, I'm going to give you my nuts and bolts explanation. Imagine that I want to receive an email notification at midnight every night with the latest articles in my blog. I want you to be able to subscribe to it, right? So you could write your app running on one computer. You could have a process that says, hey, it's midnight. Let me run through all the news stories that happened in the last 24 hours. Let me run through all the people that have requested this account. Let me go and send an email to each one. Boom, 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 boom. That would be the sort of the naive way to do this. One program, just a loop, and send the emails. Okay? The second thing you could do is, now that's not a very good idea. So what I want to do is I want to spawn a process. I want to use Sucker Punch or something like that to have something that runs in the background on the same computer, so this computer's bigger, okay, by itself, and it has a list of emails to send, because that's a data structure. I hope you guys looking at computers are still listening to me and not coding, because this is tricky, it requires your attention, otherwise I'm wasting my breath repeating it. So this thing is running in the background. Somebody made a list, it may be in a database of the people who want to get an email, and another list in a database of all the articles that have changed, and they send an email, send an email, send an email. Okay, that's a little bit better because now this is a separate process and it's a little bit better. Okay, the next thing you could do is to say, wait a second, what if I run a second computer, totally second computer? This computer is not connected to the web. This computer has no UI, it has no web pages, it has nothing like that. All it has is an HTTP REST API that looks something like, since it's an internal, it's like it's an internal server, /email /send, and the arguments is basically a list of email addresses. No, let's start with this. Before you do that, it just looks in the database, in the same database, because they're sharing a database. It looks in the same database when it's told to send. Actually, I'm going to pop up even less. This thing is sitting here all day long. I'm looking at this database. And whenever a record comes up that says, whenever it sees that it's midnight, it looks in here and decides who to send the email to. Now it's a separate computer all by itself. It knows very little. It doesn't know anything about blogging or journalism or anything like that. All it knows is its life in the universe is to look in this database at midnight, find all the articles that have changed, find all the people who have subscribed to it, and send them an email. If this computer crashes, this computer goes along happily and doesn't care. Just no emails are going out. And when it comes back alive, it can look inside the database and send whatever emails it left behind. Yes?
So with the left box you drew for the computer, would that represent like a back end?
Yeah, it would be invisible to the outside
This
world.
kind of plays along with the whole REST thing where you have layered layered technology. Whatever.
Yeah, it's using, in this case, it's not using REST, because in this case we said just look in the database. You know, they're sharing a database. But you still have a little problem because now, you know, this is a dependency. These two things are connected to each other, which might be okay. So this, I can actually stop here and say this is a service-oriented. This is a. I'm getting myself. I would call this a service-oriented architecture. Except, although in this case, the service is not required to be communicated by the main app. It's just using the database as a place to find out what work to do. But this is totally modular, right? So if suddenly you have so many emails, here's scaling out. Suddenly people are complaining that their password change, and you've all experienced this, their password change email it's taking 5 minutes or an hour to show up. And that's a scalability problem because people are complaining about it. And that's because we have so many people in the site, it's Facebook, and people are changing their password so much that this poor guy can't keep up. He can't send the email. Okay, I changed this job now. This guy's job now is to send a password change email. And the way he does it is that he receives a message from the main Facebook app, and that message is a post password change email for user 73450. So this is HTTP between these guys, post, and this guy knows that his job when he gets this message is to look in the database for this user and send him a password change. Very nice, except what's going on is we have 100 or a billion users on Facebook, which means that at any particular second, there's 100,000 people changing their passwords, and they're starting to complain that their password change emails are either not showing up at all or showing up really late. So what's neat about this now is that Facebook can decide to create a second server, scaling out, running exactly the same code as this guy, and receive the message at the same time, and either one of them can satisfy the message and send the email out. Okay? So this is a service-oriented architecture because we have totally separate computers. They're getting instructions using HTTP REST calls, and the instructions are telling them what to do, and the main app can keep on providing the normal default service of this application. Does everybody understand this at a visceral level? Conceptually, you all understand it. Can you visualize how this would work? Okay, this is the micro example of how you would do scaling up. So what had to happen here? Sorry, did you have a hand up?
Oh, I just wanted to make sure that I got everything clear because it was a lot. But is it basically that that this server, its only job is to send messages?
Yeah.
So
That's one important.
That is the service. That is the sending message
Exactly.
service.
Yes. And that's called the app. Pretend it's one big thing.
So that's everything else, but in
Everything
reality, that would be a bunch of other stuff.
It could be more so because then you could see go on.
So, but then all of the different services ask this specific service to send a message whenever it needs to send a service.
Exactly.
So that none of the other apps are concerned with sending messages.
Exactly.
And so if this message goes down, that means everything else is fine.
Exactly. Exactly.
Okay.
And a couple of wrinkles that this brings up that nobody's. I have a mistake on here. I want to see if anybody can catch me on it. And so look for the mistake as I keep talking. There was something you said that made me want to pick up on it. But yes, you described it correctly. So these would. Oh yeah. What I want to say is realize that I can only scale out my email services if I had designed my software to allow it. Right? This is a re-architecture. This means that no longer can some controller in here decide to send an email. Somehow, this controller has to instead send a message to the email service to do it. So it's a fundamental architectural change. And that's why scaling up is easier, because scaling up requires no fundamental architectural change. Scaling up just says get a bigger computer. Now, anybody find a mistake yet?
There's a question while you're lost.
Yes.
How do you prevent the same email sending?
That's the mistake. Boom. The way I drew it here, the same email is going to go out twice. All right? Ding, ding. So let's improve this. The way we improve this is there's one classic way to improve it, which is to use a message queue. So a message queue, you guys all know queues as a primitive data structure inside of an app. Okay? A message queue takes that same idea and uses it as an alternative way to connect two services together. So if instead of sending a REST API, I put a message queue. You can look up, for example, MQ series, there's RabbitMQ. there's even, okay, it doesn't matter. But imagine instead that there's a queue that floats in the inside the data center somewhere, and that both these guys are looking at it. So, and this guy's looking at it too. And these queues correspond to the emails that need to be sent out. Now, the service just puts the information on the queue, and these guys take them off the queue as quickly as they can. If they both crash, this queue is going to get bigger and bigger. Eventually, it'll overflow, and that's what happens. That's when you start not getting your password change emails. If people are complaining that it's going too slow because I have a gigabyte of memory here, so I can actually have 1 million emails outstanding, except the emails take an hour to show up, I can just add another e-server, and everything stays the same. This is classic scaling out. Okay, so if you architect your app in the right way, and I'm not saying you guys should do this in your app, this is more like some basic principles of scalability. If you architect your app in the right way, then you can add and delete servers that do a certain service depending on need. Yes?
This queue would have to be synchronized in some way, right?
Yeah, it is. And the essence of the queuing services like RabbitMQ, and there's a bunch of others, is that. There's a few things about it. One of them is that it's synchronized to make sure that there's no corruption. The other one is that there's all kinds of parameters as far as timeouts are concerned, and as far as how big the queue is. You can decide what to do with it.
Where is this queue stored though?
It's its own service.
It's its own service.
It's its
Okay,
own
that makes
service.
sense. Yeah.
Exactly. So actually, it's its own service. And this guy can register to create a queue, and it has its own disk. That's another service. In fact, if you look around Amazon AWS, Amazon Web Services, they have one of the services is a queuing service. That's how you would use it. Okay? So this is scaling out. Very basic but advanced technique to create scalability.
So the same principles you use to like synchronize process communication on an operating system, basically.
Same idea. Yeah. But the beauty here is the total decoupling, right?
Right.
This guy needs to know nothing about who's doing it.
Yeah.
Notice also that I didn't, as the architect of the system, decide that I wanted to have an e-server because it seemed like a good idea. No, I started with doing the email in here, and I started noticing all kinds of problems. Like people were complaining about the email taking too long, and I said, this is a common enough problem. Let's build a service for it. Okay? And you have a lot of design questions that you still have to answer. What level does this thing operate at? Does it have access to the database of A or not? Or does A have to transmit all the information needed in this queue? For example, the email it's going to go to, who to notify if it bounces, what the text of the email is. All this stuff has to go into the queue, or is it just a pointer and they access the database? What are the pros and cons of that? If this email thing is accessing the database, we create a new dependency. If we change the schema of this thing, we have to change the schema of the algorithm of this. So you got to be very careful about what dependencies you introduce and which ones you don't, because decoupling in this world is every bit as important, if not more important, than an object design. Did you have something?
Well, I don't know if there's an answer to the question you just asked, but like, I'm assuming most of the time they don't have direct access to the database.
No, there's no general answer, actually. It's an architectural decision. Yeah. It's an
What is the norm?
I can't say. I don't know if there is. Because not every system has an email service. I mean, in fact, you can get an email service as a component from Amazon Web Services as well. And you can buy third-party things. Like there's, you've all heard of SendGrid. You might not have heard of SendGrid. That's a third-party, like Heroku, it's a third-party email service, SendGrid. So that's the other thing. If these services are sufficiently general purpose, they can become a thing you sell on your own. You can be the world's most brilliant email sender. By the way, what's hard about sending a lot of emails? What is hard about sending? If I wanted to make SendGrid, and I wanted to offer it to Amazon as the way to do your email update, password update emails. What's hard about it?
People might think you're spam, and then they won't get your emails.
Exactly. That's one of the big problems. There's watchdogs out there that notice if any particular node in the network is sending a lot of emails because you're suspect of being a spammer, and you might be shut down. So it's actually hard to send a lot of emails fast. The other thing you have to do if you have an email service, you have to deal with unsubscribe requests. You have to deal with bounces and report back to the user. There's a lot of complications. Even something as simple as an email service is a snake pit of complications. And I say snake pit. But anyway, so this is sort of the crux of scaling out. Okay, and you can apply this to any part of your service, of your app, that seems to be causing a scalability problem. And I named some, rattled a few off here. It could be image services. Something like Reddit has a huge amount of traffic on images. So you can be sure that's a whole different service. Authentication. Maybe logins are slow because you require two-factor authentication, which means you have to send a text message. That's causing problems. Sending emails. Caching. Okay, so there's all kinds of things that are candidates for being separate services. Yeah?
Seems like it's like a whole fractal of like services.
It's a fractal of services. It's also a fractal of concepts because the same concepts apply at this scale as they apply in individual methods. Do you cache it? Do you do it as a queue? Do you block? One other thing I want to point out, if you were sending the emails directly from your main app, you have another problem, which is it's synchronous. You have to ask for the email to be sent and then wait until the email, whatever server you send it to is done. That creates a performance problem in your main app. So what you want to do is make the act of requesting an email to be sent as fast as possible so that the main user experience does not slow down. And that's another advantage of a queue, because putting the request on the queue is essentially instantaneous. Then your app can keep on going. If instead you were literally doing the network communication to transmit the email, you'd have a block there. It becomes synchronous. So making it async is another advantage. Okay. Let's talk about caching. Remind me, I have 20 minutes, right? Yes. Caching. Who knows what caching is and how it applies here? We've asked it before, but it's an important thing to have the tip of your fingertips, tip of your tongue. Can you say what caching is? Okay. Who should I bother? Who should I bother? Can you say what caching is? Yeah.
Instead of like going back and like pulling out templates.
Yeah. So that's a special case of caching. What's the general description of what caching is?
I mean, it's making data more available faster.
But give a little bit more. So what technique by doing?
By storing it.
So you're talking about distance. If I store it in the local LAN network versus you have to get it on the cloud. Distance is one reason to cache. But the general point is yes. Did you have your hand up? No? I thought I saw. Sure. Go ahead.
It's just to get better performance.
Yeah.
So like if you have one thing that you're accessing over and over, instead of doing the calculations to generate the same thing, you just store it somewhere.
And this should be at the tip of your coding pencil as an option for speeding up any piece of code. If you're asking for the same result multiple times, and that result is expensive to compute for whatever reason, either it's far away, or it's very big, or it takes a lot of calculation, whatever it is, you might be able to just hold on to the answer from last time and give it back again another time. That's caching. Fundamental. It should be as familiar to you as having breakfast. Very, very basic. Memoization. Who can give me a definition of that or an explanation of that? Very closely related to caching. Memoization. We've talked about this in this class before, have we not? Yes? Yes.
I'm not sure how it applies in scalability, but in algorithms, when, especially like a sort of dynamic programming algorithm problems, you can save the results of previous computations in like an array or some sort of hash. That way you don't have to recompute previously computed results.
Yeah. Memoization is shorthand for I have a method or a function or a subroutine, whatever you want to call it, and before I do what I'm supposed to do, I actually have held on to the answer I gave last time. So memoization is just caching, but it's used in the vernacular as being caching when applied at the micro level in one call. It is kind of caching. Very, very simple technique, but very basic. Now you said you don't know how it applies to scale.
Well, that would make sense.
No. It was a fair point, actually.
I just, the context that I heard it in was mostly for algorithms.
No, but I mean, I wasn't actually teasing you for once. Actually, I was saying it's a legitimate question. What does it have to do with scalability? Because on the face of it, you're talking about one subroutine. How can that even affect this stuff? Well, sometimes scalability problems come because you have one routine which is just being called a million times, and it's supposed to compute a random number between 1 and 1,000. But that's a bad example. But it's supposed to, do something, and it turns out that of the million calls, they fall into 5 categories. And if you catch those first 5 and get an instant answer to them, you can make that algorithm faster, which makes your whole system faster. So sometimes scalability problems are traced back to a stupid implementation of a little algorithm. It's very possible. You might find that, for example, just to make something up, in a database, one of the very fundamental ways of getting performance and scale is indexing, right? I want to take this column in my database and make it an index, a unique index, so that whenever somebody does a query on that column, it goes really fast. Turns out, of course, if you do this, and we talked about this, that your finds, your selects, your lookups go fast, but your updates go slow. Because if I change a value from 100 to 1,000, I have to also update the index. Well, that's an algorithm, the index updating. If you were working at Oracle and you were responsible for that algorithm that updates indexes, you can be sure you are tuning that algorithm to the umpteen level just to get, change your big O, change your speed of add a little cache here or there, whatever it is. So sometimes individual small micro algorithms can actually have a profound effect on scale. Okay. Let me see what I want to do here. Okay, I think I'm good. Okay, so let's talk about load balancing. Another fundamental concept in architecture that is used for scale. Load balancing is this. If I have, and let's talk about Heroku, these are dynos. They call them web dynos if they respond to HTTP, it's sort of the front end of your app. And you can ask for money how many you want. So you could be running your product from this class on Heroku and discover that it's slow and decide that what you need is more power executing your basic Rails code, your controllers, your routers, all that stuff. So you say, great, I can go to Heroku and say, instead of one web dyno, I want 3. And they each run Rails and run your app, in fact. They're each on a network talking to your Postgres server. And they each respond to HTTP like any app would. They each have their IP address, obviously, because they're computers. Every computer that's on a network has an IP address on both sides. It's got an IP address for talking from the cloud, from outside, and it's got an IP address to talk to the database. All right? Here's the problem. If I do, and the thing is called, let's call it Tito's app, .heroku app.com. It has an IP address. What now? Somebody makes a request of this URL. How does it get, and which of these does it get to? What? Yes. You see, that's all a load balancer does. A load balancer is another computer in here that actually has that IP address, and it decides which one to forward that request to. How would it decide? How can it decide? What are some of the ways in which it can decide? I'm going to go with the left side of the room this time. How would the load balancer, do you understand what the load balancer does conceptually? How would it decide what to do here with the request? Somebody refresh the page, they want to see it. How would it decide?
How long could it be like, how long does it take to receive the request from either of the servers?
So in other words, you're saying it somehow knows this guy's slow, this one's faster.
Check the response time of each server.
So whatever did last, the last time I asked it, if it took n microseconds, I'll remember I won't give it more because it's getting slow.
Yep.
Yep, that's one way. So that would be called an intelligent load balancer, and it's paying attention to the. Well, no, why would one be slower than the other, by the way? Why are they not all the same speed? Yes.
That's what they're requesting from the database.
Yeah, exactly. Right. Or it could be that these are not exactly the same size computers, or one may have more memory than the other. Whatever it is. Okay. What other way could you imagine this happening? Yes.
Sequentially.
Yeah, round robin, taking turns. Now you don't really need to worry about this in Heroku, but if you were building your own, if you were building a big commercial system, you would be running your own load balancer. And really, a load balancer is nothing more than another computer, and it basically is running only in the network stack, and it's basically receiving the get from this side, having a list, and saying I want to use this computer, and copying that get over and issuing it to the other computer, getting the answer and sending it back. So it's literally just, they call that a proxy also. A proxy. Or in this context, it would be called a reverse proxy. Because this is proxying, it's standing for these three guys. So if you hear these terms of proxy, you've heard of a proxy in terms of something on the firewall in your house. This is the other way around. This is the front end of the server rather than to hide your clients. But basically, this is basically a proxy because it's making this computer look as if it is one of these guys. So load balancing, another fundamental concept in scalability. Previously, in my incorrect drawing of this diagram, I could have, instead of introducing a queue, said, no, we're going to put a load balancer here. That's going to decide based on the same principles whether to pass the request from the application server to the email node. Okay? That would have been an option. And there's trade-offs there. So load balancing, another fundamental concept. Another fundamental concept in creating scale. Now we're going to talk about database slowness. It could be that this is not the problem at all. It's no problem. The problem is here. In fact, from my investigation, this is more commonly the problem. These app servers, this Rails server, has no problem at all generating those pages because it's just running in memory. It's very easy. Turns out that this database is getting hit so much that it's answering very slowly. If this database is answering very slowly, why would this not help? Or would this help? Would creating a load balancer and additional web dynos help or not? Would it help or not?
No.
Why not?
This bottleneck is in the wrong area.
Yeah, the bottleneck is, well, say more about that. Take it down to the nuts and bolts.
We're using the load balancer to basically speed up the requests.
Mm-hmm.
But each of the web dynos are trying to pull from the database.
Mm-hmm.
So, if anything, you should have something that addresses like multiple databases.
Right. Right. Yes.
I was going to say, could it be the case where, if we use a load balancer, which essentially speeds up the transactions requested from the database, we might be pushing the database to a failure.
Possibly. You'd have to look at the rate at which the incoming requests are coming. Maybe not though. This gets into queuing theory. They're coming in at a certain speed. They're not going to come in any faster because of this. They're going to come in at the same speed. If I have right. So, but it gets hairy that way. It's not obvious. So you want to split up the database. Database partitioning is the other fundamental concept that comes into scale. Database partitioning. Okay, what are some of the challenges with database partitioning? Let's think about it. I can erase this. So I had one database, and it has in it some tables, like a user table and a products table and a shopping table or shopping cart table. And great, and this is my database, so I'm going to like that. I'm going to make this better. I'm going to have another database. It's going to have user, products, and shopping cart. Now, it's very nice. I have basically my one Rails server here coming this way, and it connects to both of these. What's wrong or what's right about this picture?
So partitioning is a copy?
Well, I took the most simplistic sense of the most simplistic concept here. So, and there's something wrong with this picture. So what's wrong with this picture? Yes.
You may have an inconsistency between the two terms.
Say again?
You may have an inconsistency between the
For example,
So let's say one of the databases falls over and you have a user save a new item to their cart.
yeah,
One database, they have that transaction recorded.
Yeah.
Whereas the other one doesn't do that. And when that database comes back online, there's going to be an inconsistency between the two. One saying there is something happening here,
Mhm.
and there's going to be another one there. So there is no authoritative source of data.
yeah, that's true. But in a simpler case, you don't have to have one of them crash. I go in and I change the price of a book from $10 to $11, and the load balancer picks this one, updates the price to $11. This one's still sitting at 10. Inconsistency. So you don't have to have, but the case he mentions is true as well. So the next thing is that all respectable databases that you know, like Postgres, Oracle, MySQL, SQL Server, they all have this thing called replication. Replication is, in the simplest, most sense of the word, is simply I can create a connection between these two guys, and whenever anything updates here, something updates in here, and vice versa. Or every 100 seconds, any changes that were happened here happen there. Does that help the case? Helps it a little bit, but really doesn't solve it, right? Because you still have the 100 millisecond or the 100 second window, and even if it was instantaneous, there's still a window. So you have to address that in your architecture. And I'm going to cut this short and just jump to the punchline. Actually, I didn't finish all the punchlines. So one thing you can do is realize that that certain transactions, like displaying the home page, does not change the data at all. Only updating the price of a book changes the data. So one thing people can do sometimes is to say that this connection is only for read requests. This connection is for read and write requests. Now, it's okay if it's only every 100 seconds that any changes here get updated, because you have a transitory moment when the answer is incorrect. Now, that's not always okay. If it's a matter of what's in my shopping cart, you can't have any inconsistency. But if it's the image showing the shoe in Amazon, it's probably okay if you have some inconsistency. So one way you achieve scale when you have to partition a database is to separate reading from writing. A lot of real-world services have a lot more reading than writing. And so it's not uncommon to see a bank of databases that goes on, all of them for reading and only one for writing. These guys all replicate. Okay, so now all your reading load is happening extremely fast, because reading is faster than writing because you have to update indexes, and your writing load goes to one server. You have a bottleneck here, so you accept the fact that updating is a slow. So exploiting this asymmetry in reading and writing is one way to go. Another way to go is service-oriented architecture, because if you had a service, if you figured out a way to have your product information all in a product service, and the database is just in the product service, and all the communication between the rest of the app to the product service went through an API, either a queue or REST calls. Now you, again, have partitioned it totally, and you can scale better because you, by definition, have a separate database. Anyway, this is a very long story, but I hope you got a taste of it. Remembering, measure first, don't assume you know why it's failing. Make a change only when you have evidence it's necessary. Measure what happens after the change. Caching, especially local caching like memoization, is your friend. It's really easy to do. Caching in general is really easy to do. So do that if you have problems. That's often the right thing to do. And indexing, which is another way of improving performance, is a huge win for very little effort. So look for the low-hanging fruit first when you have scalability problems. But first know that you have them. And there's a whole other long discussion about how do you actually measure this stuff, how do you create a test load and so on. But we don't have time for that. Cosi 105 next semester. So tomorrow you guys have everybody has their marching orders for the presentation. See you, and those of you who are not talking to your product reviewer can obviously keep on working on the product. If you're with, it's only 4 people at a time are going to be with the reviewer. 4 teams at a time.
stuff. I've started working on that like
I guess.
2 a.m. last night. What do you mean? You know how like there's a game for